All right, area and volume. So I'm not going to lie on these. I'm not going to evaluate them. We're just going to set them all up because I don't have a calculator. So A says find the area of R. So when doing this, we're first going to start. So area, we know is an integral. And then we're going to do top minus bottom here because that's the easier way. And then if you look at our x values, they go from 0. Just kidding. They go from -1 to 0. And then it's just going to be top minus bottom. So we need to figure out which one of these is our top function, which one's our bottom one. So this straight line right here, that is g of x. The other one is f of x. And obviously we know that because g of x is linear, while f of x is a square root. So it's going to be top minus bottom. We can see that f of x is on top here, so it's going to be square root of x plus 1 minus bottom, which is x plus 1 dx. I think you would just put that in your calculator. Next, we need to find the volume of the solid R when it's rotated around the x-axis. So we're rotating around this line right here. So we can tell we have a big radius and a little radius because there's all this open space, so it's washer method. So I draw both lines down, and essentially it's going to be the same thing. We'll just have two radiuses. With washer method, make sure you put a pi on the outside though. So it's going to be pi, still from -1 to 0. And then my big radius is obviously f of x down to the line. And it's going to be y equals 0 as our line there. So our big radius is square root of x plus 1 minus 0 squared. Then minus our little radius, which is going to be g of x minus 0. So x plus 1 minus 0 squared dx. And then you'd plug that into the calculator. That's how you find the volume using washer method. All right, next, we're going to rotate around the line y equals 3. So actually, I'm going to erase all this. So our line up here is y equals 3. So now the other thing that's going to change is we're still going to have to find a big radius and a little radius. But now our top function is going to be y equals 3, not y equals 0 on the bottom. So essentially it'll be the same. It'll be pi, still our x values because we're rotating around a horizontal line. So from -1 to 0. My big radius goes from 3 minus, it goes all the way down to our linear line, so minus x plus 1 squared. And then minus 3 down to our little radius, which is going to be our top function, which is square root of x plus 1 squared dx. And that's our volume around the line y equals 3. This next one is essentially the same exact thing. We just have y equals 1 now. So when I set this one up, still pi on the outside from -1 to 0. But instead of having a 3 this time, this is really going to be a 1. So it's going to be 1 minus x plus 1 squared minus 1 minus square root of x plus 1 squared dx. All right, E is where it's changing, so we're going to go around a vertical line this time. And our vertical line is x equals 2. So that's over here. So now we're going to have to go right minus left. And in this case, this equation is x equals 2. So I have to change these two to x equals. So what I'm going to do here, this is really y equals square root of x plus 1. Square both sides. And then subtract 1. So the curvy function is now x equals y squared minus 1. And then our other function was y equals x plus 1. It's now going to be x equals y minus 1. So if you're ever rotating around a vertical line, you got to change both of them to x equals. But now after this, it's going to be the same. So we're going to have pi on the outside. But again, since we changed these to y functions, we're going to have to use our y values instead. So this one's going to be from 0 to 1. And then I'm going to go right minus left. So I'm still going to have big radius and little radius. But my bigger one, I'm going to start at 2 because it's on the right, minus, that's the curvy function, so minus y squared minus 1 squared, 2 minus y minus 1 squared. And then that's going to be dy. So if you ever go around a vertical line, it's going to be dy's. Okay, f is the same thing, except now we're going around the line x equals positive 1. So this one will be from 0 to 1. Instead of a 2, we have a 1. So 1 minus y squared minus 1 squared. 1 minus y minus 1 squared dy. So always remember top minus bottom and right minus left. Okay, perpendicular to the x-axis, and it's a rectangle whose height is 4 times the length of its base. So, for cross sections, we're not going to have pi unless it's about a circle. And then this time it's going to be perpendicular to that x-axis. That tells me it's a vertical line, so I'm going to go back to using my x's from -1 to 0. Then my base is going to be my top minus bottom. So I'm going to go back to using f of x and g of x just because it's easier. So my base is going to be top minus bottom, which is f of x minus g of x. But then I got to use area, which is base times height. So this right here is going to be my base. They tell us my height is 4 times that. So 4 times f of x minus g of x. And that would be our area using a cross section. How would it change if it was an isosceles right triangle? You would just change the area. So it'd be area equals 1/2 base times height. But it's isosceles, so base and height are the same. So it would really be area equals 1/2, whatever your side is, top minus bottom, squared. Next one, we have it is perpendicular to our y-axis. That should be telling us we have to do y's. So you're going to set up your integral. It tells us from 0 to 1. Then if it's a semicircle, we know it's going to be 1/2 pi r squared. So I'm going to put the pi over 2 outside, so that way I only have my radius squared on the inside. Because pi and 1/2 are both constants, that's why they can come out. So on the inside, it's just going to be right minus left. So if I look, there's no extra line this time. Right minus left is just going to be g of x minus f of x. But since that's basically diameter, we got to cut that in half before we square it. So semicircles, you have that extra step. Whenever you find right minus left or top minus bottom, it has to be cut in half. Equilateral triangle has some weird formula. I honestly don't remember what it is. Google it. You would use the formula for it. For a square, you would just have the integral from 0 to 1. And then it would be right minus left, so g of x minus f of x. And the area of a square is just side squared. So we would take that side and square it. Always use the formula of whatever they give you. I and J, not gonna lie, I haven't even looked at these. Hold on. So what we should have done here is really we should have evaluated A to find the total area. So I'm just going to give you a piece of information here. I just don't know where that pie came from. Hold on. So the area from part A was 1/6. If you evaluated it, you should have gotten 1/6. So basically what we're figuring out here is that we know this area is going to be cut in half by some line K. So I don't know what this X value is, but it's K, and it cuts that area completely in half. So 1/2 of a 6th is going to be 1/12, and that's going to equal the area. So let's do the X ones first because that's what this one is. So it's going to go from -1 up to K where it's cut in half. And then I'm just going to use whatever I did for the area, which was top minus bottom, or f of x minus g of x dx. So again, we just took our area, which we found in part A. I didn't simplify it, that's why I didn't know it. Divide it by 2, we get 1/12. That has to be equal to the integral from -1 to K, because it tells us that's where it's split into 2 equal parts. And then very similarly for J, same thing. So it's still going to be 1/12 because the area didn't change. Equals, this time we got to use our y values. So instead of it being from 0 to 1, it's now going to be from 0 to K. And then be careful how you write this. I probably wrote it wrong up there somewhere. It really should be g of y, not g of x. These are wrong, sorry. Because it's functions of y, not x. So our right function is g of y minus f of y dy. So anytime it's talking about going around a vertical line, it should be x values. I'm sorry, that's not what I meant. I meant cross sections. If its cross section is a horizontal line, that's when we have to use our y values. Make sure you don't write f of x and g of x. It's g of y and f of y.